F is equals to m into a. Force is equals to mass into acceleration. We all know that. To determine the value of force, or to determine the value or the value of m or a, whatever it is, you have to use the equation that is the force is equals to mass into acceleration. The mass must be multiplied by to the acceleration to get the force, right? We know this equation. Now it is a time to prove that equation. So suppose let a particle with mass m is moving in a, you can consider it in a straight line or in a direction, and the initial velocity was u meter per second. Initial velocity was u, right? If F force, think about it, if F force is applied to the body, if F force is applied to the body, and the time interval of applying the force is t, right? So then the velocity of the body or the particle must be changed, because what we are doing, we are applying the force. So if force is applied in a body, the velocity of the body must be changed, and the new velocity is v. So here you have to think about it. The body with an initial velocity u, and now after applying F force in the interval of t time, the velocity now is v. It is a normal phenomena. So now think about it. Before applying the force, can you tell me what is the value of linear momentum of the body? We know the momentum is equals to mass into velocity, right? So before applying the force, the momentum of the linear momentum of the body is what? M into u. Because in the previous the velocity was u, so m is the mass of the body into the velocity of the body before applying the force. So that is mu. And after applying the force, the linear momentum of the body will be m into v. Now think about it. So in t time, right, or in the interval of time t, the change of momentum is what? The change of momentum here mv minus mu, right? Because the initial momentum was mu and the final momentum is m into v. So the change of the momentum in t time or in the interval of t time is equals to mv minus mu. That means equals to m into v minus u, right? This is what? This is a change of momentum of the body in t time or the t interval of time. So if you want to determine the rate of change, the momentum, right? Here I am repeating again the rate of changing the momentum, or the rate of change of the momentum, linear momentum, obviously it is the rate of change of the linear momentum of the body. That is what? The rate of change of the linear momentum in a unit time, or in a 1 second, whatever, in a unit time. So in the t time, the change of the momentum is equals to mv minus mu, or the m into v minus u. So in unit time, that must be m into v minus u by t, because the time interval is t, and here you want to determine the rate of change of the momentum, or you want to determine the change of the momentum in a unit time, right? So that must be m into v minus u by t. And now think about it again. If you v minus u by t is what? It is nothing but the formula of acceleration, because we know that a is equals to v minus u by t. If you want to determine acceleration, that must be is equals to final velocity minus initial velocity by t. So here you directly can write m into a, right? The v instead of v minus u by t can be written as only a. So m into a. So m into a is what actually? M into a is nothing but the rate of change of the linear momentum of this body, right? We got this. We derived it. Right? Now think about it. We know the second law of Newton. The second law of Newton is what? The rate of change of the momentum of any body or of any moving particle is directly proportional to the applied force, and the change, that means the change of the momentum or the change of the linear momentum or whatever it is, so and that change take places to the direction or in the direction of the applied force. You understand? I'm repeating again. The change of the linear momentum or the change rate, sorry, the rate must be here, rate of change of the momentum or the rate of change of the linear momentum is directly proportional to the applied force, and the change takes place in the direction of or to the direction of applied force. So if it is, that means we can directly write here F is directly proportional to MA, because F here is the applied force and MA is nothing but the rate of change of the momentum, because we have derived already that the rate of change of the linear momentum of the body is nothing but M into A, right? So we can directly write here F is directly proportional to M into A. So now F you can write instead of this proportional sign, that is F is equals to K into M into A. K here is a constant. Now we have to determine the value of K. For determining the value of K, what we need to do, we just consider the unit force, the definition of unit force. You will got to know in the next module or the next contest that what is unit force. So unit force, if unit force, that means 1 Newton, or you can consider 1 dyne, whatever it is. So if mass of the particle is 1 or unit, and to generate unit acceleration, that means 1 meter per second square or 1 meter per second square, to generate unit amount of acceleration, the force is needed or the force is given to the body, that is called unit force. That means F is equals to 1. So here think about it, if M is equals to 1 and A is equals to 1 here, so F must be 1, right? So K is equals to, so this is because this is the formula, sorry, this is the definition of the unit force. If we are applying the concept of unit force here, our value of M equals to 1, value of A equals to 1, and also value of F is equals to 1. So that means if we put what we got, K is equals to exactly 1. I am repeating here again, unit force is what? Unit force, if we are having a unit mass, the particle of unit mass or 1 kg, right? And if we want to generate a unit acceleration, suppose 1 meter per second square, the force is needed, it is called unit force, and that must be 1 Newton. Okay, so here in our case, if M is equals to 1, A is equals to 1, and also F is equals to 1. If these 3 terms are 1, and if you put the values to this equation, what we have, K is equals to 1, because F into K into MA. So 1 equals to K into 1 into 1. So K is equals to 1, and put the value again to this equation. So what we have, F is equals to M into A. That means force is equals to mass into acceleration. You can simply derive the degree of F by this equation, and if you can directly solve any kind of problem related to force, related to mass, and related to acceleration, if you want to determine force or acceleration, you can use that formula directly. We will definitely go to the critical problem, right, to the next module with related to this concept or this equation. But this is also a very important concept that can be, that can be occur in your examinations to prove F is equals to MA. Thank you very much.